Okay, in today's lesson, we're going to learn how to long divide polynomials. Before we start, we're probably going to have to define a couple words like we do in our math class all the time, and the biggest one being the word polynomial. A polynomial is something with many terms. So for example, this has 3 terms. 5x cubed is a term, 50x squared is a term, and 9 is a term. Terms are separated by addition and subtraction signs. So this has 1, 2, 3 terms. It makes it a polynomial. Over here, after the division sign, we have x plus 10. That has 2 terms. It's still a polynomial, but specifically we call polynomials with 2 terms binomials. So in this case, we have a polynomial divided by a binomial. We're going to go over some more terms as we go through steps. So for example, step 1, to long divide, we need to name some things. So the first thing we need to do is we need to name the degree. And we need to check the order of the polynomial. So the degree is the highest power of the polynomial. So in this case, our 2 powers we see, powers are exponents, is 3 and 2. So the highest degree, I write the word degree, you're going to write the degree every time, is 3. And then we're going to check the order. So in this case, it should start at the degree of 3, and each term following should decrease by 1. So this is 5x cubed. This is 5x squared. We're doing well. The next one should just be x, but that is missing. So the polynomial is not in order, and we have to reorder it. Since the x term is missing, we are going to put a 0 as a place filler there. If these terms were out of order, under this order spot, you would flip them around so they are in order. Once we check degree and order, we are ready for the setup, step 2. The setup uses the division bar that we're so commonly used to in elementary school. That looks like this. On the inside of the division bar, we are going to put the dividend. The dividend is the polynomial being divided. So in this case, it is the longer expression. This is 5x cubed plus 5x squared plus 9. Over on the outside, you put the divisor. The divisor is the number or expression that the dividend is being divided by. So when we go to set this up, we have an x plus 10. That's our divisor. And 5x, I'm going to write the rewritten version of the dividend here underneath the division bar. Our goal is to divide the dividend by the divisor to get the quotient. The quotient is our final answer that we're looking for, and the quotient is going to go up here. All right, now we haven't started any math, which means step 3 is our math. We're going to start step 3 off with some side work. So on the side, we want to divide the first term. See how the word term popped up? Of the dividend, another vocabulary word, by the first term of the divisor. Once we get it, we are going to write it on top. On top where? On top right here because it's part of the quotient. So in this case, the first term of the dividend is 5x cubed divided by the first term of the divisor, which is x. 5x cubed divided by x is 5x squared. We're going to put 5x squared right here on top. Notice how I put 5x squared above the x squared term here. We want everything in line so it looks all pretty by the time we're done. Step 4 is going to be to multiply that value, when I mean that value, the value that we just divided on the side and put on top, by the binomial, or the divisor in that case, because the binomial is our divisor. And we're going to write it in line below the dividend. So we are going to take that value, so 5x cubed, or x squared that we got. We're going to multiply it by x plus 10, which means first we have to multiply it by x, then we have to multiply it by 10, and we're going to write it below the dividend. So 5x squared times x is 5x cubed. 5x squared times 10 is 50 x squared. Step 5 is to subtract. We're going to subtract this value from the dividend. So when we subtract, we're just changing the signs essentially. So this is now negative, this is now negative. Once we put those signs there, step 6 is to add down. Note that the first values should cancel. We rigged it that way. We purposely picked the right number to put here to make it so that 5x cubed minus 5x cubed goes away. If it doesn't go away, you did your side work wrong. It just so happens in this problem, 50x squared minus 50x squared also goes away. That is not always the case. Then we have 0x. We're going to put that here, and we're going to put 9 here. Which means 0x is also just 0, so we don't have to really write that. So we just have a 9. Now, we do not have to do step 7. Step 7 is repeat the above process until we are left with a constant. In this case, 9 is a constant, so we're done. If 9 wasn't there and we had x squares and x's, we just continue to go through dividing the first term, multiplying, and subtracting until we're left with a constant. Once you're left with a constant, that is our remainder. That means we can no longer do 9 divided by x plus 10. So if we can no longer do 9 divided by x plus 10, we are going to write it on the end exactly how I just said it. 9 divided by x plus 10. You write that remainder on top of the divisor. Our quotient, remember our answer that we were looking for, is the number that remains here. In this case, we only had it being one term. In other cases, you will have it being multiple terms, depending on how many times you go through these steps. So now you're going to complete the rest of the problems, showing that you can constantly go over these steps. And by the end of the class, I would like you to complete this problem. This is your exit ticket. X cubed minus 10x squared plus 34x minus 40 divided by x minus 5. Now note, here I used a different division symbol. That's okay. You can also see it written as a fraction. like so. These are all saying divide the polynomial by the binomial. So again, this is your exit ticket, and this should be handed in by the end of today's class, along with the rest of your 1 through 6 problems. You're going to continue to follow all these steps, fill in the vocabulary, and show me that you know how to long divide polynomials.